In the previous video, we looked at the particles that make up an atom, the protons, neutrons, electrons. We know their charge, we know their location, and now we want to get a little more specific. And so there's something called the atomic number. The atomic number is the way that we identify elements, one of the ways that we can identify elements. It's really just a measure of the number of protons in the nucleus. And so like if I look at a periodic table and I say, yeah, I want to look for element number 2. Well, on the periodic table, if I look for the second element, element 2, that's helium. Am I saying that its element number 2 or its atomic number is 2? We mean that there are 2 protons. Now in the last video we also mentioned this, and it was really important. Atoms are neutral. Atoms are electronically neutral. So they have to have the same number of positive protons as negative electrons. So here, like helium is element number 2. Its atomic number is 2, which means that there are 2 protons. The protons are positive. And so there must also be 2 negative electrons. And so by definition, the atomic number means the number of protons. But if you're talking about a neutral atom, it also gives you the number of negative electrons. And so it's the same with any element, as long as it's a neutral atom. Silver, if I look on the periodic table, silver is element number 47. Atomic number 47 means there are 47 positive protons and 47 negative electrons. It's electronically neutral. So if we look at this question 10, a cross-cutting concept. Scale, proportion, and quantity. Identify the numbers of protons and electrons in these elements. So we've got fluorine, which is an element that helps prevent tooth decay, and it's found in many toothpastes. Sometimes it's added to water. It tells me here that it's element number 9. Its atomic number is 9. If I look at a periodic table, in the box with the symbol F for fluorine, I see a 9. But if it's element number 9, by definition, there must be 9 positive protons. Put a little positive in there. And there must be 9 negative electrons. So that overall the charge is 0, neutral. Iodine is an element used to clean skin before surgery. It's really a solid, but it's often used in solutions. It is element number 53, which must mean that there are 53 positive protons and 53 negative electrons. You could use the little P for proton or the E for electron as well. Should add up to something electronically neutral. Super easy, right? And again, maybe something that you've done in a former science class where you're like, oh my gosh, I'm so smart. Cool. Okay, so all of these elements then are housed in this fantastic thing called a periodic table. Now, there's all kinds of things that are really interesting about the periodic table, and obviously we're going to study it inside, outside, left, right, top, bottom, forwards, backwards. This is it. I mean, this is going to like rule your life for the next couple months, I guess. And so it'll show us that there are symbols. Obviously, we can shorten up the names of the elements, and sometimes there's 1 letter, sometimes there's 2. Every periodic table looks a little bit different, to be honest with you. This periodic table here is not the greatest. There's usually 2 numbers in the box. There's always 1 number that's smaller, and it's a whole number. That's the atomic number. So like all of these little numbers up on top, like this 2 right up there, or here it is, bloop. Oh, I went on top of it. That's the atomic number. atomic number. Now, again, they don't show on this particular periodic table, but there's usually two numbers in the box. The atomic number will always be the smaller number. The smaller number in the box. And it'll always be a whole number. So, for example, I'm looking at a periodic table on my wall. And I have a box for helium. I have a little 2 up in the corner, and then down at the bottom it says like 4.0026. And eventually you'll look at a periodic table more similar to this. So obviously the symbols are always going to be the same no matter what periodic table you look at. Some periodic tables will give you the word name. I have one on the wall that does and one that does not. So you might see like the word helium in the box, which is kind of nice. You'll never ever have to memorize the element symbols. It's not worth it. For any test or quiz, you can have a periodic table on your table. So the more you use the periodic table, you will just get more familiar with the symbols. And a lot of them you may have guessed anyways. Helium, like maybe He, as opposed to hydrogen, which is just H. And I get that some of them are kind of goofy, like copper is Cu and tin is Sn. Well, a lot of those come from like old Greek or Latin roots. Like copper comes from cupric, and tin, Sn, comes from stannic. Some of them are maybe not what you would expect, and that's okay. In that case, we just look them up. But you don't have to worry about trying to memorize 118 elements on the periodic table. That's what it's there for. It's meant to be a resource. Now, depending on what periodic table you look at, sometimes the atomic number is on the top, sometimes it's on the bottom. It could be in a corner. That changes depending on the periodic table you're looking at. But the atomic number will always be the smaller number in the box, and it will always be a whole number. Whereas the other number is bigger, and it always has some decimal spots to it. And we'll deal with that number later on. Now we're just looking at the atomic number. Okay, cool. This periodic table has different columns and different sections colored. Some of them do, some of them don't. That is kind of nice about this one, because then when I get to question 11, I'm going to infer about the groups on the periodic table. What might those colors mean? Why are some groups different colors? Based on the organization and colors of the periodic table, which two elements do you think are most similar in terms of their properties? So magnesium is Mg. It's element number 12. It has 12 protons and 12 electrons. Barium is Ba, 56 protons and 56 electrons. And gold is Au, number 79. That's another one that's from like old Latin root words. Now, who would have thunk Au for gold? Okay, so based on the organization of the periodic table and the colorings, what did you say for question 11? Which two elements do you think are most similar in terms of their properties? Did you maybe say like the magnesium and the barium? Yeah, I would have thought so. I mean, just based on their colors. Explain. Yeah, they're the same color. They're in the same group. We call them groups going up and down. It's rows or periods going across the periodic table. So maybe you said, yeah, because they're in the same group, they're the same color. Maybe that means that somehow they have similar properties. If you did say that, you would have been right. And that's what we'll eventually study too. Like, once we kind of know all about the atom, like what makes magnesium atoms similar to barium atoms and what makes them a little different, then we can really start diving into the specific elements and what makes their properties similar and what makes their properties a little different.